Welcome back to my YouTube video channel. I'm Sadiq by name, a student of Federal University of Technology, Minna. Now, my last video based on power series solution of ordinary differential equation using the higher derivative and Leibniz theorem. Today's video based on Leibniz-Maclaurin method, using Leibniz-Maclaurin method. So these are the 5 steps to follow. The first step is to differentiate the given equation using Leibniz theorem. Rearrange to put x equals to 0. Determine the value of y0 and y1. Substitute your value into Maclaurin equation. This is Maclaurin equation. We have to put it into Maclaurin equation. Now simplify the result where possible and apply boundary condition if given. So let's take a look at example. So example 1. So we have to find the power series solution of the equation this using Maclaurin theorem. The first thing to do is to rewrite. So we have x y prime prime plus y prime plus xy equals to 1. So that's the first thing to rewrite. Now here I can get my u to equals to y prime prime. My un equals to yn plus 2. Then our v equals to x, v1 equals to 1. Now from this area is only u that we have, so u equals to y prime, then un equals to n plus 1. From this area, so we have u equals to y, un will equals to yn, and v equals to x, v1 equals to 1. Using this formula, yn equals to, the first method is to use Leibniz theorem to solve it. So we have unv plus n, un minus 1, v1. So the highest power of v is 1. So we don't need to add more. Now my un from here is yn plus 2 dot my v is x plus n. We should minus 1 from it, so we have n plus 1. This we minus 1 from it dot 1, our v1, then plus my un here is yn plus 1, then plus this side my un is yn, then our v is x plus our n, this is n, then we minus 1 from here, so we have n minus 1, y raised by n minus 1 dot 1, everything equals to 0. So if we rewrite, we want to have dot x plus n, y n plus 1. Now we can see that n plus 1 is common, so we can factorize n plus 1 out. So if we factorize, we have n plus 1 in bracket yn plus 1. So from here I've taken out n plus 1 dot, now this is yn dot x plus n yn minus 1, everything equals to 0. Now the second step is to make x equals to 0. So I have to make x equals to 0. So if I make my x equals 0, so this one will be 0. So we have n plus 1, yn plus 1. This is one is also is 0. If I put 0 here, so we now have n yn minus 1 equals to 0. Now take this one to the other side, so we have n plus 1 equals to minus n yn plus 1. So now yn plus 1 equals to minus n yn raised to power n plus 1 over n plus 1. So we divided both sides by this. We divided both sides by n plus 1 to give us this side. Now the next thing is to find appropriate value for n. Now we have to follow this order. Right? If you have y2, it will give you y naught 0. If you have y3, it will give you y1 0. If you have y4, it will give you y2 0. And if you have y5, you're going to get y prime 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 0. So we have to follow this order. Now this order we have to follow is that if you come here, what value are you going to put for y here? This is our left hand side and our right hand side. From this left hand side, what value are you going to put for n to get y2? Now, once you get y2, definitely you're going to get y0 here. So what value are we going to put? So we now say n equals to 1. So if n equals to 1, we're going to have y prime prime. So if you put 1 here, so that's 2. But we write it as prime prime equals to n. So if I put 1 here, so it's the same thing as is 1. Anything multiplied by 1 is 3. So we have we're going to have 1 minus 1, which is 0, over 1 plus 1. So, but we're not going to write y0, so it is written. So this one gives us minus 1 over 2 y naught. So it is written like this. So if you have y0, it is the same thing as y, this y. So now we have n. When n equals to 0, we are going to find 6 series of this. When n equals to 0, so we have y prime. So if I put 2 here, so that will be 3. 1, 2, 3 equals to minus. If I put 2 here, so I will have 2 over. If I put 2 here, I will have 3 in brackets of y. It is 2. So 2 minus 1. So we have y1 0. Now when n equals to 3, we have 3 plus 1, that's y4, equals to, if I put 3 here, so that's minus 3 over 4, y prime prime 0, because 3 minus 1 give us 2. And if n equals to 4 now, so we have y5 equals to, if I put 4 here, so I have minus 4 over, this is 5, minus 4 over 5. So you're going to have y1, 2, 3 here. Now, the standard series we're going to find must be 6, like 6 number. 1, 2, 3, 4. So we need 2 more, but we can stop at 4. Yes, you can. Once you've gotten the 4 series, is okay. But the standard is to find 6. So let's stop at 4. You can find the remaining 2 yourself. Now, the next now is to make everything to be in order of y naught and y1. So we have to convert everything to y naught and y1. This one is y naught, this one is y1. So we need to change these two. So if I want to change these two, so I'm going to have minus 3 over 4 multiplied by, what is our y2? So if we go back, our y2 is minus 1 over 2 y naught. So which is going to give us 3 over 8. So we're going to have 3 over 8 y naught. Now the same thing here. What is, you have value 4 over 5. So what is our y3? My y3 is minus 2 over 3 y1 equals to 0. So minus cancel minus, so we have 8 over 15 y1 0. So we've gotten the value. This is y naught, this is y1. Now we are going to put, the next stage is to substitute the value that we've gotten into Leibniz-Maclaurin theorem, which states as yn equals to, so we have y naught plus y xy 1, this is 1 not, plus x square over 2 factorial y prime prime not, plus x cube over 3 factorial y prime 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 not, plus x raised power 4 over 4 factorial y raised power 4 not, plus x raised power 5 over 5 factorial. Then we have uh, x raised power 5 over 5 factorial, so we have y5 not. Now we are going to put in every of our value into this. Now y naught is constant, so it remain y naught, plus x y1 is also constant, so it remain that. So we have x square 2 factorial is the same thing as 2. Now what is our y2? Y2 is minus 2 over 3 y prime not, plus x3 over 3 factorial, that is 6, over what is y3? Y3, oh sorry, y2 is minus 1 over 2. Sorry for that. Then y3 is this is y3, so this is y naught. So y3 is the same thing as minus 2 over 3 y1 plus x raised power 4 over 4 factorial is 24. Then what is y4? This is y4. We have 3 over 8 y naught plus x raised power 5 over 5 factorial is 120. So I can decide to write it as 4 times 24, 5 times 24 over what is y5? So this is our y5, 8 over 15 y1 not. So now the next thing is to rearrange. We rearrange. So we now have y naught plus this is y naught. So this is because of this, so it will change to minus x square over 4. 2 times 2, that's 4 y naught. So this is another y naught. So you're going to have x raised power 4 over 3 here 1, 3 here we have 8. 8 times 8, that's 64. 64 y naught. So that is for y dot. Now plus x y naught plus another one here we have this, so it's minus x raised power 3 over 9, because 2 here 1, 2 here is 3, 3 times 3 is 9 y1 naught. Then another one is this, which is positive, so 8 here 1, 8 here we have 15 3, that's 15, 15 times 15, that's 225 I think. So x raised power 5 over 225 y1 naught. Now from here we can see that y naught is common. So y naught is common. So if you factorize y naught, you go to have 1 minus x squared over 4 plus x raised to power 4 over 64. That is for y naught, plus y1 now, we go to have x minus x cubed over 9 plus x raised power 5 over 225. So this is our final answer. Thank you for watching the video.